Welcome to On the Road with Bill Holub podcast.
Hello, this is Bill Holub from Steam Trap Survey, LLC. This is our second podcast. We'll be talking about ultrasonic testing of steam traps.
Hello, this is Jessica Holub from Exclusive Social Media. I do Steam Trap Survey LLC's media, such as social media, book edits, training videos, and more. Explain the difference between digital and analog ultrasonic.
All right, so digital and analog ultrasonic, they're basically doing the same thing. Digital is a device like this. It's an ultrasonic device that is a digital readout, such like this, which you probably can't see. But the digital readout is in decibels from 1 to 50, let's say. Analog, same type of device, but instead of digital numbers, it reads in bars. So 3 decibels per bar in this case. Those two are both general purpose. Whenever I'm in a hazardous environment, this is an analog ultrasonic tester, but it's good for class 1 div 2, basically the same thing. It reads in analog.
Explain the difference between general purpose and intrinsically safe.
General purpose is used in areas where there's no chance of explosion, where sparks can happen and nothing bad's going to happen. So both of these, this is a general purpose. I can use this in a food plant. I can use this in a beverage plant, pretty much any type of plant. When you go into a hazardous environment where you don't want to have a spark happen, that's what intrinsically safe is. Intrinsically safe means this device here is designed so that no spark can happen outside of this unit. So this could be used in refineries, chemical plants, anywhere where you have a class 1 div 2 classification that you have to respect.
How many different types of steam traps are there?
There are 5 different types of steam traps. First, you have inverted bucket, then you have thermodynamic, then you have float and thermostatic, then you have thermostatic, and then you have venturi. All 5 of those, pretty much every manufacturer makes, with the exception of, there's a venturi company that'll sell venturis. There's float and thermostatic companies and thermostatic companies that don't sell venturis. Maybe they don't sell inverted bucket traps. But all in all, there are only 5 different types of traps. What really is important too is there's only 2 modes of operation. And that's what we'll discuss a little further when we go into discussing each type of trap during the next question.
How do you determine the condition of an inverted bucket steam trap?
Well, you have to use an ultrasonic device. This is an inverted bucket steam trap right here. This is the bucket inside. It moves up and down. When it goes up, it closes the trap. When it moves down, it opens the trap, letting the condensate through. You can tell the inlet of the inverted bucket trap usually by this little device here. That's where the steam and condensate will flow down and then up into the bucket and around and out the orifice and then exit back to the boiler room. So when you go up to these inverted bucket traps, you have to know that 1, it's an inverted bucket trap. 2, it's an on-off trap. So that's a mode of operation, on-off mode of operation. So when you check it, you're looking for these decibel ratings here on this analog type device. Each one of these red lights is 3 decibels. And you don't want a decibel jump from here to here more than 10. So what you do is you go up here and you'll test it on the inlet, see what the decibel reading is or how many lights are lit up. Each light is 3 decibels. Check it here on the outlet. Check the decibel rating. If it's more than 4 lights lit up above the inlet, then you know you might have a failed steam trap. Also, it will be loud if that bucket is opening at the time you're checking it. So make sure you check it a couple times just to make sure it's not in an open position.
How do you determine the condition of a thermodynamic steam trap?
This in front of me is a thermodynamic steam trap. You can tell by a cap. You can tell by, there's a disc inside here. You can't really tell that, but the fact that you see a cap like this that typically is a thermodynamic steam trap. Thermodynamic steam trap has a cap, it has a disc inside, and then it has the body. The body is where the disc slams down. When it slams down, it's shut. So this is an open and closed steam trap. So what you want to do, again, is check it with ultrasonic. You want to check the inlet. You want to check the outlet. Just like the inverted bucket trap, you want to make sure that you don't have a 10 decibel jump across the inlet and the outlet. However, if the trap is open, you're going to see that increase in decibels. So you want to make sure that that trap closes before you consider its condition. This type of trap will open and close. It's not a continuous, it's open and close. So you want this thing to have a tight shutoff. But when it closes, you can have wire draw on the body, which is steam, which will just eat away at bodies, the body and creates a path where steam can get through and leak by even though it's closed. So when you're testing it here and testing it there, you want to make sure that you're not jumping 10 decibels, and you also want to make sure that when it's closed, that the decibels are the same on both the inlet and the outlet.
How do you determine the condition of a floating thermostatic steam trap?
This again is a floating thermostatic steam trap where you can see this float rides up and down in the body. Condensate comes in, float moves up. Condensate goes out, float moves down. So in this case, this particular trap is a Valon trap. This particular trap is always open until you get steam in there. So when you test this particular trap, you want to check it again on the inlet. You want to check it again on the outlet. Same 10 decibel range applies with this as well. This is a continuous trap, so you're not expecting it to close. You're expecting no more than a 10 decibel across that inlet and outlet. But what you'll hear on this thing is you'll hear kind of a wave sound where you're going to get some condensate through, maybe no condensate through. You're not going to hear a lot of live steam. Typically what happens with floating thermostatic traps is when the float fails, it doesn't float anymore. So you're not going to, and typically when the float fails, maintenance will have that fixed because it's cold by the time you get there. Typically when you go and test a floating thermostatic, you're hearing a thermostatic element fail on you. The thermostatic element is inside. So that could fail open on you. So that's where you're going to get your decibel range where you can consider that particular trap fail open.
How do you determine the condition of a thermostatic steam trap?
You determine a thermostatic steam trap by using ultrasonic like everything else. You want to see the decibels not higher than 10 going across the inlet and the outlet. This is a continuous trap, so you don't expect it to close. Thermostatic traps come in a lot of different types. This is a bimetallic. There's a capsule type. There's a bellows type. There's a C dimension type. And there's a thermostatically set temperature type. It just doesn't really matter because they all operate based on temperature. Again, inlet, outlet, no more than 10 decibels.
How do you determine the condition of a Venturi steam trap?
Venturi steam traps are a continuous type of steam trap. They're an open hole. They're sized based on the application. Each application is sized independently. This one particularly happens to be one for a drip leg, so the internal orifice is very small. However, when you're testing it, it's the same principle. It's a continuous trap. It's not an on-off trap. You don't expect it to close. But what you want to do, again, is the same thing. Inlet, outlet, no more than 10 decibels. Typically, when you hear this type of trap, an ultrasonic, it sounds more like a steam locomotive where you get two-phase flow, steam, condensate, steam, condensate, steam, condensate. If you get a rushing sound of a lot of steam, very high-pitched, over 10 decibels, it could be the fact that the trap is, the Venturi is oversized. May have to relook at that sizing. Or it could be that there's some of the Venturis have an internal orifice that may fall out. I've seen those fall out before, and that's something you just want to listen to, and you'll be able to hear that using an ultrasonic device.
Thank you for joining us. Look forward to our next podcast.